If you like this video, make sure to visit our Vimeo page and follow us to get the latest update.
What is the common database approach? Here, the concept is very, very important here. So one is we need to talk about the transactions. One is we need to talk about the transactions. And the second one, we need to talk about the analytics. Okay, very, very important. So the second thing, we need to talk about the analytics. What is a transaction? When I see a system, when a system was built, when I see the system was built, okay, so we call it as a 3-layer architecture. Okay, come to the point number 1. Okay, so should we discuss about what is the R3 architecture? Why do you call the SAP, and why do you call the SAP business suite, and why do you call the SAP business suite on HANA? There are 3 things we have discussed yesterday in the class. When I see a transaction, this is my system where we are going to be posting the transactions in the presentation, and this is my application, and this is my database. Okay, very, very important database. This system was completely built only for the transactional system, where we can call it as, in terminology, in SAP terminology, we can call it as OLTP system, online transactional processing. We can call it as the online transactional processing. So every day-to-day transactions during a manufacturing of a product, any transaction you take, whether it is the purchasing related, or it is the finance related, or it is the asset accounting related, or a controlling related, or a sales related, any transaction you take. Okay, all the transactions we are entering from the presentation. From the presentation, it will go to the application. From the database, from the application, it will go and store in the database in a form of a tables. Every transactions are going to be stored in a form of a tables. Very, very important. Table is the main data structure. There are 2 types of differentiating the tables. Actually, there are 2 different storage types of tables are there. One is going to be calling it as a columnar storage. Second one, we call it as a row-based storage. We can call it as a row-based storage. Okay, the database is, okay, the database tables are 2 different storage types. One is going to be called as a columnar storage. Another one is going to be called as a row-based. There is advantage is there if we want to move from the row-based to the column-based, and there are some disadvantages also there. If I want to continue with the column-based, not with the row-based, I'll discuss about the row-based and the column-based in the coming class, not a worry. So what is happening? The database is going to be having the multiple tables. For example, if I'm posting a transaction, salaries account debit to cash or bank account credit. This is a transaction. We can call it as a transaction. In this transaction, there are 2 line items are there. One is going to be called as a debit line item. We can call it as a debit line item. And the second one, we call it as a credit line item. When the transaction got posted, the transaction will go and store in the database in a form of a tables. What are the 2 tables we are going to be discussing? I'll discuss about the 2 finance table. One is going to be called as the BKPF. Another one is going to be called as the BSEC table. One is going to be called as the BKPF table. Another one is going to be called as a BSEC. Example, just I'm giving an example. Okay. At a few period of time, something like I'll take about 6 months or 7 months. Very, very important. Or after 1 year, I want to extract a report. I want a report to be get extracted from this particular OLTP system. This OLTP system was completely built only for the transaction, not for the reporting purpose. Not for the any kind of historical reporting purpose. I'm not going to be using this OLTP system. Only for the transactional processing, I'm going to be using the reporting system. Very, very important here. So when I want to extract a report for the management reporting side, for example, so what is happening? This particular architecture, what you have designed, this is only for the transactional processing, where it will not support any kind of analytical reporting system. Now, what I had to do, I need to increase my okay, comprehensive means I need to increase my technical architecture into 2 different. One is going to be called as OLEP. Another one is going to be called as the OLTP. So the database was designed in such a way that databases are not going to be supporting for both OLEP and OLTP. Initially, I'm talking before SAP S4HANA comes into the picture. This system was completely built for OLAP purpose. What is OLAP? Online analytical processing. Online analytical processing, very, very important process. This is also 3-layer architecture where I'm going to be using the presentation, where here I'm going to be also having the application. And here we have the common called as a database. Database. Very, very important here, database. So every month end or something like every quarterly, there is a job is going to be running between the OLTP to OLAP system. Background job is going to be scheduled every day or every week or every month or whatever may be. So what this job will do, there is a bad job. We can call it as a bad job. A bad job will be scheduled between the OLTP system to OLAP system. So what this batch job will do, it will extract the data from the OLTP database system. It will extract all the tables, means it will extract the data from the database tables. And what it will do, it will transform and it will load the data into the OLTP system. We can call it as the ETL process, extraction, transformation, and loading the data. Very, very important. Very, very important. Why should I extract the data? Why should I transfer the data? Why should I load the data into the database? Because earlier there is no common database. There is no common database where the database will support for both transaction plus analytics. No. What do you mean by analytics? Analytics is completely we are going to be using for the reporting. Very, very important. Analytics is nothing but we are going to be using for the reporting. Only for the reporting, we are going to be using this analytical system where we can call it as a BI system. Very, very important. We can call it as a business warehouse information system. Very, very BWI system. We call it as a BWI, business warehouse information system. Very, very important. Where the system is also called as a reporting system. For only for the reporting, we are going to be using this OLAP system. So if I want to, if I ask if I'm going to be sending a request to my BI consultant to extract the report and give the report to me, the data should be available in the database or not. If the data is not available in the database, I cannot develop the report and give it to you. So where the data is available, the data is available in the OLTP system, not in the OLAP system. So what I have to do, I need to extract the data, I need to transform the data, and I had to load the data into the BWI system, that is business warehouse information database system. So the data should be available here, means all the tables data should be available in my system here, so that whatever the report you're going to be asking, I can develop the report and I'll give it to you. This is only for the reporting system, for the information system only. This is not do any kind of transaction. I'm not going to be posting any kind of transactions in the OLAP system. No transactions are getting posted in the OLAP system. This is only to build the report and give the report to you. So how much time you are going to be taking to give the report to me? Approximately, when you see the report with, for example, with 100 GB of the data, just an example. If you want a report which consumes the data, which has the data about 100 GB of data, approximately to develop this report by the BI consultant, they're going to be taking up to 30 to 40 minutes. Very, very important, my dear friend. 30 to 40 minutes they're going to be using, they're taking the data, they're taking the time to get a report to be developed and give the report to you. This is the BIW system, business information warehouse system here. So in 2009 and 2010, actually in the mid of 2009 and 2010, very, very important, very, very important. So they have introduced the concept called as accelerators. They have introduced the concept called as accelerators. What do you mean by an accelerator? Accelerators are nothing but to improve the performance of developing the report from the BIW system. Very, very important. So I'm using some concept called as the accelerators. So what these accelerators will do, it will minimize the time actually. So it will improve the performance of executing the report from the OLAP system. And instead of taking with the 30 minutes, approximately it will take about 50 minutes. So it is reducing the time to half a time. Very, very important. Earlier, the same report before the accelerators, it is taking 30 minutes. Now the same report, by using this accelerator, It is taking 15 minutes. Okay, it is better. It is better to get the report back to me in 15 minutes. So then the system name, we are going to be calling it as BWA system, BWA, Business Warehouse Accelerators. Very, very important point. So these accelerators have been introduced in the year of 2009 and 2010. So we are using these business accelerators to extract the report and give the report back to the management. So what is happening here? So for the transactional processing, you are going to be using one system, and for the analytical reporting, you are going to be using one system. So can I call it as a heterogeneous landscape? Definitely, we can call it as a hetero. Okay, we can call it as a heterogeneous landscape process. Very, very important. These are certification questions are also coming from this point. Very, very important. So we call it as a heterogeneous landscape. Very, very important here. So your landscape is very complex actually. We can call it as the landscape is a very, very complex. What is the landscape? First of all, I want to know what is the landscape. Okay, so you are explaining the landscape by differentiating the two different systems. One is the OLTP system, another one is going to be called as the OLAP system. Means you're increasing your hardware or not. You're increasing your hardware. If I get a database, if I'm going to be getting one database, which will serve my purpose of both OLAP and OLTP together. Okay, right. So what is your understanding? I want a one database. It has to serve both OLAP plus OLTP in one database system. Then I will not use this OLAP system at all. If there is no database which is not having the feasibility to get the data and I want to transaction the data into the data, if there is no database, then I need to dependent on the two different landscape process. One is for the OLTP, another one is going to be called the OLAP process here. So then you're going to be running some bad jobs. You're extracting the data, you're transforming the data, and you're loading the data into this new database system. And you're using some accelerators to develop the report and giving back the report to you. And that report is mainly useful for the reporting purpose. Means the OLEP system we are only using for the reporting purpose, and OLTP system only we are using for the transactional process. This is what exactly we are going to be using till before 2011. Till 2010, I can tell it. But after 2011, the changes, there are drastical changes have been happened at the database level. I'll explain you the concept. So is it clear here why we are going to be calling it as the OLTP and why we are going to be calling it as the OLEP database system? Anybody has any doubt here? Before I go to the point number 2. Parallelly, I will open the certification material also. Parallelly, I will open the certification material and I'll also study the certification material for you. What exactly the meaning of OLAP and OLTP has been given here. I'll take. So now, tell me, anybody can tell me now, how many types of data you are going to be extracting from the OLTP to OLAP and how much time it is going to be coming? What type of data you are going to be pulling? Somebody can tell me what type of data? One is transactional data. I'm right or wrong?
Correct.
Yes.
Second one. Where you're posting
Master data.
Master data is only the thing we have. Without the master data, I cannot post any transactional data. Very, very important. Master data is different. Master data is different, and the transactional data is different. What is the master data? What is the master data? A master data is a core information which remains for a long period of time without any changes is called as the master data. If I don't have the master data, I cannot post any transactional data. Definitely. For example, if I want to make a transaction like this, salaries account debit to cash or bank account credit. If I don't have the master data for this particular transaction, I cannot post any transactional data. So the first one is going to be called as a transactional data is very, very important for me. Where the transactional data you're posting, the transactional data is posted in the OLTP system. And the second one is going to be called as analytical data. Very, very important. Analytical data. What is this analytical data here? From where this analytical data you're going to be getting? Analytical data I'm going to be getting from the OLAP system. The second one is there are 3 types of data. One is a transactional data. Second one is analytical data. Third one is acceleration data, very, very important. So these three points are very, very important. Third one, we can call it as an accelerator because you are using the accelerators. Because you are using the accelerators. So there are three forms of data you're going to be using: transaction, analytical, and acceleration. So this database was designed. This database was designed because earlier we don't have a one common database approach where it is going to be supporting both for OLTP and for both OLAP system. So in this form of triggering, I'm using a separate OLTP and separately I'm using the OLAP system. Very, very important. So what we have done here after the 2011, SAP has brought a database where we are going to be calling it as a SAP HANA database. It is also called as the in-memory database. I'll talk to you what is the in-memory in the coming classes. So now I got a new database which was introduced in the year of 2011. Very, very important. In the year of 2011, I'm going to be calling it as. So we call it as the in-memory DB. Why do you call it as a in-memory DB? I'll explain you in the coming class. Very, very important. The in-memory concept is a very, very important here. So now what is this SAP HANA is telling me now? Hey Mahesh, now today I built a database where both OLTP plus OLAP is going to be having these advantages in the single database from today onwards. Means what does it is telling that? No need to do the extraction, no need to do the transformation, and no need to do the loading of any database, any data from the OLTP to the OLAP. So your both OLAP plus OLTP is going to be performing in the single database system where I call it as the SAP HANA in-memory DB. So what you're going to do now, if that is the database, now I'm going to be getting only one type of data directly, only one type of data. That one type of data is nothing but your reporting data. Very, very important. You're going to be getting the reporting data from a single common database now from today onwards. What is the database is called as SAP HANA. So that is the reason where I'm going to be calling it as a common database approach. Common database approach. So here is the diagram we can see here. 1 second. 1 second, please. 1 second. 1 second, please. Very, very important. This topic is very, very important. You will expect 2 certification questions from this particular topic. At least 2 certification questions will come. Okay. Let me open the material now for you, all of you. Give me 1 second, please. I'll be also sharing all the materials what I'm going to be displaying on my desktop, because all the materials will be available. And apart from that, okay, whatever the materials which are not available in your block, I'm going to be sharing those materials. So no need to get any material from the outside, or don't purchase any material. So whatever the material you want, okay, just ask me. I'll provide all the materials to you, okay, from the ZaranTech. Okay, very, very important here. 1 second, please. I got it. Yeah. Okay, this is about the diagram which I want to explain you. Okay, so this is how you can see here your transaction. There are 3 copies of data in different model, and there is the inheritance. Okay, there is the inheritance data latency, and there is a poor innovation for leading to the wastage also. Very, very important. Poor leading to the wastage also. What is the inheritance data latency? When you are extracting the data, when you want to extract a report, for example, this particular database, what I'm going to be using for the OLTP system, when I want to extract the same reports from the OLTP database, not from the OLAP database, what is happening? You can see there is a very, very poor latency. We can see here. What is the latency here? What do you mean by latency here? Latency is nothing but the time which is taking to extract the data, and the time which is taking you to compile the report and giving back the report to you, where this is very, 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 very poor innovation, leading the wastage of the time and wastage of the latency. Very, very important point here. So I cannot use this OLTP system for the reporting purpose. Why you cannot use the OLTP system for the reporting purpose? One major reason is whatever the data you are going to be getting from the databases. For example, if I want a report called as a customer aging report. Last demo also I told that customer aging report, very, very important. For this customer aging report, approximately the data which I am extracting from the database table, about minimum 5 to 6 tables are going to be used. 5 to 6 tables are going to be involved in extracting the data from the database table. Very, very important point. So now, once you extract the data from the underlying database table, what the query will do? The query will, what it will do? The query will send the data back to your application. See the latency now. See the latency here. Very, very important point. In how many tables the data is going to be stored? If I want to build a report called as a customer aging report, approximately 5 to 6 tables are getting involved. So once I extracted the data, once my query got extracting the data from this all the 6 tables, actually the database has to compile the reports. It has to compile all the 6 tables and it has to form a report and it has to generate the report back to me. Very, very important here. Very, very important. Now, what is happening? The database is not only serving me the purpose of storing the data, but not compiling the reports. All the 6 tables has to compile. Table number 1, table number 2, table number 3, table number 4, table number 5, and table number 6. All the 6 tables, what it has to do, it has to compile into one report. Actually, it has to compile into one report. This is how it has to be happen. But what is my database is going to do? The database is only using to store the data in the database table. If I want to compile the report, this query, what it is going to do, this query is pushing the data back to the application. Means all the 6 database tables are getting pushed to the application, because application is a server. Application is called as my kernel level software. The compiling should not be happened in the application. Compiling should be happened in the database. But earlier, whatever the database I'm going to be using, whether it is the Oracle database or it is a DBMS database or it is the RDBMS database, I'm going to be calling it as a secondary access device. I'm going to be calling all the database systems are going to be called as a secondary access devices. Very, very important, my dear friends. The terminology is very, very important here. Terminology is very, very important for me. So what do you call the Oracle database or other databases? We are going to be calling it as a secondary access devices. Why do you call it? I'll explain you. So the data will be stored in a form of a database table, and the extracting the data from this database table is in the disk processing mechanism. Disk processing, very, very important here. It is going to be called as a disk processing mechanism. When you are using the disk processing mechanism, you can see very poor latency and poor innovation in extracting the data. You can see the wastage of the data is going to be very, very high when you are using the disk processing mechanism. Okay, there is no concept of parallelization and the partitioning. There is no concept. Earlier, we don't have the concept of parallelization and the partitioning. Very, very important, my dear friends. Very, very important point. These all are going to be. I'll tell you what is the parallelization partitioning. There is no concept of parallelization and the partitioning. I can see the very poor latency and the poor innovating of extracting the data from the database table. Why? Because these are all the database tables. These are all the databases we are going to be calling them as a secondary access device. And the processing of the data is completely based on the disk processing mechanism. I'll tell you what is the disk processing mechanism. So because of there are so many disadvantages are there in my earlier legacy database. So what this query will do, it will extract all the data from the 6 tables, and instead of compiling the data in the database, this query, what it will do, it will bring all the 6 tables here to the application. It will bring all the data to my application. All the database tables, 6 database tables. Each and every database table is having about 20 to 30 mg of the data. Very, very important. Or GB of the data, whatever you call it as. Okay. So All the 6 tables are getting pushed to my application. And what this application is going to do, now the application has to compile the data now. What this application has to do, this application has to do the compiling of all the 6 tables. See, my dear friends, you are doing a lot of, means what we are going to do, we are giving a lot of work to my application. Instead of giving the application work, you have to move this, you have to dedicate this application work to the database. But no, I cannot do that activity. Why? Because these all are going to be called as the secondary access devices. They are not the primary access devices. They are the secondary access devices. So now this application, what it will do, this application will start compiling of all the 6 tables. After the compiling is done, then I will be getting report back to my presentation. Are you not calling it as a postmortem report? Are you not calling it as a postmortem report? Why do you call it as a postmortem report? Actually, I want this report to be get extracted and give the report within 30 minutes. Very, very important, because this is very, very important for me for the management reporting purpose. But when you are going to be getting the data, I'm getting the data in the next day. Okay, I'm going to be getting the report next day, not today, next day. Very, very important, my dear friends. How much time it is going to be taking? It is taking hours of time to extract the report and give back the report to me. And sometimes if the reporting compiling is taking more than 15 to 20 minutes, it will go to the runtime error also. It will go to the runtime error. Definitely. What my basis people are going to do, they're going to keep one runtime error. If the report compiling is taking more than 15 to 20 minutes, definitely the report has to go to the runtime error, because the data in each and every table is very, very high, very, very important. Means the query extracting the data from the underlying database table, the data is going to be very, very high. The system has failed to compile the report and it has given the runtime error to you back. No, I cannot give the report back to you, because the report application compiling runtime error I kept up to 15 minutes. If the compiling is taking more than 15 minutes, definitely the report has to go for the runtime error. So the report will fail to extract the report and give the report back to the presentation. So because of this, there are so many disadvantages are there in the OLTP system. Because of that, what I'm going to do, I'm building a one more system that is called as the OLAP system.
I'm sorry,
yes, yes, sir, please.
Oh, I'm sorry. Before you go to the OLAP, I just wanted to ask a couple questions just about the OLTP. So you explained it very well. One of the questions that I had is, you mentioned that there's compiling at the database level. So the example you gave is there's like 5 to 6 tables, right? So there's compiling there. And then are you also saying that at the application level, there is compiling as well? Like,
exactly. Good question, sir. No.
Okay,
I'm
so
not doing
compiling is happening in both. Okay.
Exactly. No. See, where the data will be stored, sir? Data will be storing in the database in a form of a tables. Am I right or not? If you want any kind of data, where the data has to go, the data has to, the query has to go to the database and it has to look out for all the required tables. Then it has to compile the report. Then the report will be compiled and it will be observed in the presentation layer. I'm right. Now, what is happening? Now, what is happening in this case? You have all the data secured in the database tables. Very, very important. So for this customer aging report, how many database tables are going to be involved? There are totally 6 database tables I want totally, because to develop this report, I want all the 6 tables has to be get compiled. So what is happening? This query has extracted the data from all the 6 database tables. Due to the processing of the disk processing. What is the disk processing? I'll tell you. This is what exactly the disk processing. I'll tell you the disk processing. See here.
Okay.
Now this is the database table, sir. I'm taking one of the table. This table name we are going to be calling it as a BSEC. We call it as a BSEC table. It is a line item level table. SAF. Okay, line item table. Very, very important. Line item table for general ledger accounting, for the GL accounting. For the GL, very, very important. For the GL accounting, I'm taking only one table. Okay, out of 6 tables, just I'm going to be using only one table. The table name is going to be called as the BSEC table. Very, very important here. Now, when the query has entered into the BSEC table, when the query has started doing the activity to extract the data from the BSEC table. In the BSEC table, there are hundreds of processors going to be working. Hundreds of processors are there. Very, very important. Not only one or two, there are hundreds of processors going to be having in the BSEC table. So like this, for example, I'm just giving a 1 to our example.
Makes sense so far.
Okay, like this, there are hundreds of processors there. Each and every process, in each and every process, the data is available. So what this query will do, actually the query has to get splitted into multiple queries, and it has to go into each and every processor, and it has to extract the data. That is the concept, we call it as a parallelization. That is the concept, we call it as a parallelization. That is the concept, we call it as a parallelization. Very, very important. Very, very important. This is not the R, this is called as the P, parallelization. But now what is happening for this query is not dedicated. Actually, what it means by this query is not going to be dedicated to each and every processor. First, the query will go into the processor 1. And whatever the data which is required for the developing of the report, it will extract the data from the query 1, that is in the processor 1. So once this activity is completed, automatically the query, what it will do, it will go to the next processor. It will go to the next processor. What is happening when this activity has started in the processor 2, automatically the processor 1, the processor 3, processor 4, the remaining all the processors are getting locked automatically. There is called as the locking mechanism. This is called as the locking mechanism. We have the locking mechanism. Why? Because it is a completely based on the disk processing mechanism. So in the disk processing mechanism, we can see the locking mechanism is there. So until or unless if the processor activity is not completed, very, very important, the remaining processors are not getting activated. Very, very important. So once this activity is completed, this processor will, this query processing will go to the next processor. And the next processing activity has started, automatically the processor 1 is getting logged, and the remaining all the processors are getting logged. And once it has completed the second one, then it will go to the third one. Then it will go to the fourth one. Then it will go to the fifth one. So tell me now, how much time it is going to be taking to extract the data from one table that is called as the BSEC table? Tell me, sir, how much time it is going to be taking? Because earlier there is no concept of parallelization and the partitioning mechanism. So now, this activity is not only with one table. This activity is combinedly doing for all the 6 tables. Same processing is happening for all the 6 tables. So after this activity has completed for all the 6 tables, now I got the data. Yes, I got the data now. From all the 6 tables, I got the data. This is including of all the 6 tables. Now what the system has to do, actually what the database has to do, it has to compile the report like this. Table 1, Table 2, Table 3, Table 4, Table 5, and Table 6, like this. It has to compile the report by joining of all the 6 tables. Once you join the 6 tables, then I will get the report back to my presentation. Oh, this is your report. This is called as a report called as customer aging report. So this is what exactly I'm going to be calling it as a compiling of the report. Compiling means nothing but joining all the 6 database tables, and it will develop a report, and that after the report was developed, it will push the report to your presentation. So actually this kind of compiling should be done in the database. But what my database is going to do, because you are going to be calling it as a secondary access device, very, very important, and it is working as a disk processing mechanism, I can only extract the data from the underlying database table, but I will not compile the report. So what this query will do, it will get all the 6 database tables, and it will take the 6 database tables to where? To the application. It will take those 6 database table to the application, and this application, what it has to do, it has to start doing the compiling. Very, very important. What is your application? Application is a kernel level software. It is not a database. Application is a kernel level software. So what I'm going to do, I'm going to be keeping a 15 minutes runtime error concept here. Why? Because application. There is no other way. If something goes wrong with my application, the entire SAP will collapse 100%. There is okay, complete. You are going to stop your SAP until or unless you are not going to be fixing those errors. So what I will do, my basis people, they are going to keep 15 minutes as a runtime error. If the report compiling is taking more than 15 minutes, it will go to the runtime error. Very, very important. Means your report was not developed. It will go to the runtime error. Very, very important. It will go to the runtime error. So I'm not doing the compiling in the database, sir. I'm not going to be doing the compiling in the database. I'm only this query, what it will do, it will extract the data from all the 6 database tables, and the query will take all the 6 database table to the application, and it will ask the application to do the compiling actually. So once the compiling is completed, then the report will be shown in the presentation. This is what exactly the logically we are going to be using in the legacy database approach in the OLTP processing. Now it's clear, sir?
Thank you. Thank you. That was helpful. Explaining like the disk processing as well.
Now, what you have to do here, because I'm talking about the small report, but if I want a report for my management historical reporting, I want to do the planning. For the planning purpose, I want a customer aging report for 3 to 4 years of data. Tell me now, 3 years or 4 years of data, how much data? This is only for 6 months I'm talking here. But if I want a report, go back and get me the report for 4 years of data, the same report for 4 years, not for the 6 months. Definitely, I cannot use the OLTP system for the reporting system. Definitely, I cannot use the OLTP system. So that is the reason I'm going to be developing one more system landscape, which is going to be called as the OLTP system. For that purpose, I want one more system. That system name, I'm going to be calling it as the OLAP system. What is this OLAP system is called as online analytical processing. So what I do here, I will now whatever the data which is required to develop the report in the OLAP system, that data is available in the OLTP system, not in the OLAP system. So I will extract the data from here and I will transmit and I will load the data into this OLAP system now. Because if the data is not available, then how my BW consultants are going to develop the report? There should be some data should be available in my OLAP system. Then only I can develop the report and give it back to you. So that is the reason we are using this concept of ETL processing between the OLTP plus OLAP. So now if I come here, you can see here. So 3 copies of data in the different data models. Yes, one is going to be called as a transactional, second one is going to be called as analysis, and the third one is going to be called as accelerate. So you're using this ETL processing. So there is a separated transaction plus analysis plus acceleration process. Definitely, if I see my diagram here, so your transactions are going to be happened in the OLTP. Your analytical reports are going to be happened in the OLAP, and you are using this accelerated to develop further report into the accelerated data. So 3 types of data. One is transaction, analysis, and the acceleration processing. Now, what is SAP is telling me now? So if you shift your database to the SAP HANA DB, if you want to shift now, for example, this is your legacy database. This first box, you're going to be calling it as the legacy database. Now, the same thing, if you compare with your SAP HANA DB, what I'm going to be calling it as now, one atomic copy of the data for both a transaction plus analysis, all is going to be happened in the in-memory database. I'll tell you what is the concept of in-memory in the tomorrow's class. Very, very important here. In-memory is a very, very important point. We have to talk about what is the in-memory database. Why do you call the SAP HANA DB as the in-memory database? Now, we are using the SAP HANA DB. Now, no need to do this extraction, transformation, and loading the data. Why? Because this is the database where I'm going to be using called as a single data model. Single data model means a common database approach for both transaction plus analysis plus acceleration. So I'm including all these 3 types of data into one database. What is happening? I'm eliminating the unnecessary complexity and the latency. Now today onwards, there is no latency for you. Why? Because now today onwards, I don't want to use this disk processing mechanism. Now there is no disk processing mechanism from today onwards. So because I'm introducing a concept called as the parallelization and partitioning. Very, very important. I'm introducing a concept called as parallelization and the partitioning mechanism. What is this parallelization and the partitioning mechanism will do? Very, very important. This parallelization and the partitioning mechanism, what it will do, it will remove the unnecessary complexity and the latency. Earlier, the latency you can see here. Earlier, the latency is very, very high. In here, the data latency is very, very high. Now you can see I'm removing the latency concept. What is the concept of latency? Now I'm bringing the concept of parallelization and the partitioning. Now what this query will do, instead of doing this activity as the disk processing mechanism, now I'm coming out from the disk processing mechanism. This query will be get splitted into multiple queries now from today onwards. Automatically. What this query will do, once it has entered into the database table, depends upon the number of processors which are going to be working in the database table, automatically the query will get splitted into multiple queries, and each and every query will go to each and every processor automatically. Now there is no locking mechanism at all. Processor 1, processor 2, processor 3, processor 4, like this. Each and every query will go to each and every processor. So this is called as the parallelization mechanism. Today onwards, we are going to be using the concept of parallelization. Earlier, the same concept when I'm using from the disk processing, the extracting the data from the database table, it is taking up to 30 minutes, for example. Now the same, when I'm using this parallelization mechanism, even I'm not taking more than 3 seconds. Where is the 30 minutes? Now tell me, where is the 3 seconds? Why? Because I'm using the concept called as parallelization and the partitioning mechanism here. Instead of locking the data between each and every processor, very, very important. Now I'm building a partition between each and every processor. Now each and every processor is completely isolated. Now there is no locking mechanism between the one processor to another processor. So I'm splitting your query into multiple queries, and each and every query will go into each and every processor, and it will extract the data and will give the data to back to you. So that is what exactly the mechanism what I'm going to be using. That is going to be happened in my DRAM. DRAM is nothing but database RAM. We call it as the in-memory database. Very, very important concept. So the point number one is I'm going to be eliminating the unnecessary and the complexity and the latency, and very, very important, less hardware to manage also. Second point is less hardware to manage. What is this less hardware to manage? My dear friend, the concept is very clear. I'm using the concept called as a common database approach. What do you mean by a common database approach? Common database approach is nothing but a database which was designed for both OLTP plus OLAP. The database which I designed, this is for both OLAP and for both OLTP. Now, do you require this OLAP system from today onwards? Do you require this OLTP system from today onwards? Do you require this OLAP system from today onwards? Do you require both the system? If I'm going to give you in one box, if the one box is going to serve you both the purposes, why do you require the multiple landscape processing system? Why do you want to increase your hardware? Why do you want a system for both, for OLTP separately and for both OLAP separately? So I can use only one database from today onwards. I don't want this concept of OLTP and OLAP. So this is what exactly you call it as the less hardware to manage. You're minimizing your hardware now. You're minimizing your hardware. I'm removing the transactional processing, analytical processing. I'm bringing both online transactional processing into one database system. That is what exactly I call it as the SAP HANA DB. That concept we call it as less hardware to manage. Third point. Accelerated through the innovations, accelerated through the innovation, that is for simplification plus in memory. What is this concept? Earlier I'm using some accelerators. Earlier means before I shifted my database to the from the legacy database to the SAP HANA DB. Very, very important. I'm using the concept called as the accelerators. Why do you introduce these accelerators? To improve the performance of developing the reports. I'm using the concept called as the accelerators. Now, do you require these accelerators? If there is no OLAP system, then why do you require these accelerators? Tell me. I don't want to use these accelerators at any cost. I don't want to use these accelerators. And one more important thing, if you go back to your traditional approach, your CPU, this is your hardware. This is what exactly your application. This is your database. The data traveling between the CPU and your database is very, very far away. Very, very important, my dear friends. I'm talking in the legacy, not in SAP S4HANA. This is your CPU, where your application, and this is your database. The request sent by the CPU from the database, the traveling between the CPU to the database, the data between the CPU and the database is very, very far, very, very far. And you can see a lot of bottlenecks, and the latency is also very, very high. One second, please. One second. Okay, sorry. So whatever the CPU which is requesting for the data from the database, very, very important, my dear friends. So I can see there is a very poor innovation and the latency between the CPU and the database. I see there is a bottlenecks which are going to be happening at the time of 11th hour or the 12th hour. I want to avoid those kind of bottlenecks. Very, very important for extracting the data from the database. So very, very important, acceleration through the innovation plus simplification plus in memory. There is a concept of in memory that I told that I'll be explaining in the tomorrow's class. Before that, I want to explain what is this simplification now. What is this simplification? What do you understand the concept of simplification? I'll give one example, small example I'll be giving you. I'll be giving you a small example. All of you might have, okay, the consultants who have already worked in SAP ECC, they can understand, but I'll make you understand to everybody. It's a very, very important concept, actually. Very, very important concept. We have underlying database tables. These two are going to be called as the underlying database tables. Very, very important. Underlying database tables, very, very important. The concept I'm going to be using called as the underlying database tables. I'm writing here, underlying DB tables. Can somebody tell me what are the two underlying database tables for FI? Example, just any two database tables. One is BKPF.
BSEC.
And another one is going to be called as the BSEC. Very good. Another one is going to be called as the BSEC. Very, very important, my dear friend. There are different forms of the database tables we have earlier. Earlier, we have the different forms of the database tables. We have secondary index tables, very, very important. Pool tables, aggregate tables, cluster tables, like this. We have a different forms of tables we have earlier in SAP ECC. I'm talking. So on the top of each and every database tables, we can see there are some aggregate tables are there actually. These all are going to be called as the aggregate tables. On the top of your database tables, you can see some aggregations are going to be happen. Because to improve the performance of the report, I'm going to be using this aggregation. Very, very important. These are all nothing but it's a hierarchical mode actually. On the top of your database tables, there are some aggregate tables are there. I'll tell you this point when we are starting the actual financial classes. Very, very important. These all are going to be called as the aggregate and index tables. Very, very important. In between each and every index aggregate table, there is an index tables will be there. Like these all are going to be called as the index to improve the performance. These all are going to be called as the index tables. So you can see this is the hierarchical. This is the hierarchy of database tables. Earlier in SAP ECC, I'm going to be talking. Some of them are going to be called as aggregate tables. Some of them are going to be called as index tables. Why do you require this index and aggregate tables? Because I'm writing some additional DB logic to improve the performance only. To improve the performance, I'm going to be using this aggregation. to improve the performance. To improve the performance of the report or to improve the performance of acceleration, I'm going to be using this additional DB objects. There are only two DB objects. One is the BKPF, another one is going to be called as the BSEC. But I'm writing additional piece of code. My developers, what they're going to do, they're writing some additional piece of code on the top of your database table to improve the performance. So the 70%, actually the 30% of the logic which is available on the database, that is going to be enough. But what you're going to do, you're writing an additional piece of code which is comprising about 70%. So your developers, what they're going to do here, they're writing some additional piece of code on the top of your database table. Means they're increasing the volume of the database in the database table. Why? Because this is to improve the performance, actually, Mr. Mahesh, not for other purpose. To improve the performance, I'm going to be writing some additional piece of code and I'm writing some additional objects on the top of your database table. So these database tables, these tables, whatever the logic you are written on the top of your data, these tables are going to be called as aggregate tables. Very, very important. Aggregation, and these are going to be called as index tables. These are going to be called as index. These are going to be called as index tables. There is a separate class is there on this. There is a separate class is there on this. So this is what happening in my SAP ECC from tomorrow, from today onwards. What is the SAP S4HANA is telling? I don't want to read this data from the appendix tables and the index tables from today onwards. I don't want this kind of aggregation and the indexion. I'll explain beautifully in the next class. Just I'm giving the definition for the simplification here. Just I'm giving the definition for the simplification. Don't worry about that. Okay. So SAP S4HANA, what it's telling now, I don't want this kind of developing the additional piece of code or DB objects on the top of your database tables from today onwards. So I'm going to remove this kind of approach from today in my SAP S4HANA with a HANA database approach. So I'm simplifying your process. Earlier, instead of using with 11 tables, 10 to 11 tables to extract the data, the same data I will give you from one table from today onwards. Very, very important. Earlier, if I want a report to be get generated, I'm using 10 tables. I'm using 10 tables, which include the database tables, which include the aggregate tables, which include the index tables, which include the cluster tables like this. There are 10 tables I'm going to be involved. But today, I'm simplifying your data. Instead of extracting the data from the 10 tables, now you will get the data from the one table from today onwards, Mr. Mahesh. That is the simplification, what I'm going to be doing. This is just an example. There are a lot of examples out there. In the coming classes, we will see a lot of simplifications in SAP S4HANA from the finance side. This table, what I'm going to be calling it as, it is called as Universal Journal Entry Table. We call it as ACDOCA table, ECDOCA table. Yes, you believe or not, instead of using 10 tables to extract the data, now all the 10 table data is available in only one table, my dear friends. So see how the simplification has been happened. So you are going to get all the data from the one table, that is called as the ACDOCA table. We call it as a Universal Journal Entry Table. Universal Journal Entry Table. What is ACDOCA? Accounting Document Actual. What is ACDOCA? AC stands for accounting, DOC stands for document, A stands for actuals. There are two types of data. One is the planned data, another one is called as actual data. For actual data, I'm going to be giving a separate table. For the planned data, I will give a separate table. For the planned data, we should not refer to the ACDOCA. There is another table called as ACDOCP table, ECDOCP table. And for the consolidation, I'll give you one more table. Don't use this ECDOCP table. For consolidation, ACDOCU table. You can use ECDOCU, consolidation data. Now, I have minimized, I have decreased hundreds of database tables into 3 different database tables, ECDOC A, ECDOC P, and ECDOC C. Very, very important. So this is one of the simplifications. So what is SAP is telling me now? Now your accelerators are through the innovations and through the simplifications placed in memory. So I have done a lot of simplifications when you come to the database level. Very, very important. Now what I'm going to do, instead of, yes, come back to the original one. So where the compiling is going to be happened, the compiling is going to be happened in the application. Now today, what I'm telling to all my customers. Now, no need to do the compiling in the application. Your compiling is going to be ended in the SAP HANA DB itself only. No, application is a kernel level application software. So I should not compile. I should not give any compiling data to your application. So instead of doing the compiling at the application level, from today onwards, all the compiling will be happened in the database level from today onwards. Whatever the report compiling I'm going to be talking. Very, very important. By this, I'm reducing the runtime errors in my system. Earlier, per day, earlier means before you come into the SAP S4HANA with the SAP HANA DB. Earlier, if you go and see the reports, how many runtime errors, hundreds of runtime errors you can see in the report. But today, I'm going to minimizing those runtime errors from today onwards. Now, there are no runtime errors if you are going to be using the SAP HANA DB. Why? Because I'm using the concept of parallelization and the partitioning, and I'm going to be using the concept of compiling the report in the HANA DB, not in the application. So if you shift if you move the database from the Oracle DB, now I don't want this Oracle DB, Mr. Mahesh. Now, instead of Oracle DB, please, DB migrate should be done to my SAP HANA DB. Now give a new DB to me. I call the DB is going to be called as SAP HANA DB. This is called as the SAP Business Suite on HANA. Now, no need to do the compiling at the application. What I will do all your data extracting and the compiling, everything is going to be happened in my SAP HANA DB. That is what exactly you call it as a accelerate through innovation concept. That is what exactly you call it as an accelerate through innovative concept. What is the in-memory? I will explain you the concept in a detail in the tomorrow's class. What is the in-memory? Why do you call the SAP HANA DB as the in-memory DB? So now you're going to be getting all the three types of data in one database. Very, very important. Your transaction plus analysis plus accelerations, everything is going to be happened in one single database. That is what exactly I call it as SAP HANA handles transaction and analysis from a single data structure model. That is what exactly we call it as a common database approach. Is it clear now, all of you? Friends, is it clear?
Yes, yes, ma'am.
Yes, thank you.
So yes, Mahesh. So in new SAP HANA, there is no layer of application, right? It's direct table to report.
Direct table to report. Everything is going to be happened from the in-memory. Now there is no traveling distance between the CPU. Just I given the CPU. Now your CPU. Now there is no traveling distance between the CPU and the DB. Now what I'm going to do here, my dear friend. So if I go to here, so if I remove the CPU from here, just bring your CPU very near to your application. Now see here. Now I'm bringing the CPU very near to your database. This is your CPU and this is your database. So you have an in-memory database. Now your CPU will consume the data from the in-memory. The travel distance between the CPU and the DB is very, very near. Now you cannot see any kind of bottlenecks at the 11th hour or 12th hour from today onwards because of in-memory. I'll tell you the concept in the tomorrow session. Don't worry.
Okay.
So if I come to this, so let me go through this. Okay. Now what the points SAP has telling. For more than 20 years, organizations have been using a specialized software using with additional hardware. Definitely. One is for the OLTP, another one is for the OLAP. To extract, to transform and load to the data from the transactional system. What is the transactional system? OLTP is going to be called as a transaction system. So you're extracting, you're transforming, and you're loading the data from the OLTP to OLAP. This is from the past 20 years, we are going to be using the same system. Okay. So if we come down to the dedicated reporting system, what is my dedicated reporting system? OLAP system. So where you are going to do this transaction, extracting and loading the data to my OLAP system. Based on the technology available at that time, this was the optimal way to provide a holistic view of business data with a good response time. Because the database was designed in such a way that there is a separate database was designed for the OLTP. There is a separate database designed for the OLAP. I can't use only one single database for both OLTP and for the OLAP. Very, very important point this is. So your online processing, this means nothing but your OLTP was separated from online analytical processing. The reason for this is nothing but database design. Why? Because of the database design only, I'm going to be using the OLTP separately and OLAP separately. Quite simple, a database model were either to build for the OLTP or you're building the database for the OLAP optimization. Very, very important. For the OLAP optimization, for but not the both. See, there is a word is called a but not both. What do you mean that? Mean that I cannot have both OLAP and OLTP in one common database approach. This is the struggle what we have went up to 20 years, you believe or not. This is the struggle we have went up to 20 years struggling with a common database. Because, and very, very important, the very bad is nothing but we don't have our own database till 2011. SAP has come out with the database in 2011 that is called the SAP HANA DB. Till 2011, we don't have our own database. We are the tenant of other database systems like Oracle, RDBMS, DBMS, Microsoft DB, Pascal DB. We are going to be using a different DBs. So our struggle ends after we came out with the SAP HANA DB with the optimization. So however, this all brought with the complexity, redundancy. Redundancy is nothing but a duplication of the data. And of course, the latency. It was unusual for the today's business, blah, 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 something for tomorrow analytics. Yes, definitely I told that. What I told that, if I want the report to be get today, but I'm going to be getting the report tomorrow morning, you cannot call it as a post-mortem report. Mahesh, I want the report for today for the management reporting. You're telling that you will get a report tomorrow morning. What is that? No, there is no other way because I need to extract the report from the OLAP system, not from the OLTP system. So you have to wait until next tomorrow morning so that I'll give the report to you from the business warehouse application system. Very, very important. It's a very bad. It's a very bad. So that's the reason it is very bad. That's the reason what I'm telling. The database supports SAP S4HANA. SAP can handle both OLAP and OLTP for processing for a single data model, and therefore we do not need to move the transactional data to the separate system from today onwards. What's that? Okay, so we do not build. This means your transactional plus analytical application runs off on the same tables, and therefore data is available in the real time. The concept we are going to be using called a real time at every level of detailedly explained. So this is the diagram tomorrow I thought of explaining you. Okay, removing the complexity with the SAP S4HANA. Tomorrow I'll explain this concept, why all these database tables, why these aggregations have been removed, and why there is a common database approach at the database level, why this additional DB was written, why this additional code was improved to improve the performance. Tomorrow's class is very, very important. Just we have explained only the complex, just we have explained the understanding about the acceleration and innovation with the in-memory database. Very, very important. This is the today's class about OLAP plus OLTP, both are combined. We call it as a common database approach or single data model. How the class is today? How the class is today? Are you getting the
Great.
Yes,
yeah,
it was
it's good.
Very, very important.
Very good.
Two things are there. Critical
It's
and
good, Mahesh.
yeah, very, very important. Thank you, sir. One thing is nothing but you are the functional consultant, but you can ask me a question. Hey, Mahesh, this all the technical knowledge is going to be required. Definitely it is going to be required. You can only call yourself as the SAP S4HANA consultant when you know all those things. If it doesn't know what is happening in the back end, if you're only watching the movie on your silver screen, but what is the hard work which was spent by the directors and associate directors and the producers and the cameraman in the back end, if it doesn't know what is the hard work, then watching the movie in the front end is not important for you. So you have to know in the back end what is happening, what is happened, so that I'm going to be getting this kind of reports. So these all are very, very important. For a certification, you are going to be getting one question or two questions, but for a knowledge, you're gaining a knowledge, a beautiful knowledge for all the backend system, how the system is going to be behaving if I'm going to be using this kind of reports. So this one diagram is very, very important for you, my dear friends. I'm going to be sharing this all the materials to you, not ever. This one diagram will consist of a lot of information on that. So tomorrow we'll see about the in-memory and this removing the complexity. Tomorrow we'll discuss about the in-memory by removing this complexity with SAP S4HANA. Good.
Yeah, Mahesh, can you ask the guys to place this one recorded material?
Definitely, sir. I think it is already available. Okay, so yesterday's recording is already available. If we go see here, sir, today's
Yes.
recording will be available. So if I go to the
Oh,
video
it's available?
recordings,
Okay, okay.
if I go to the video recordings, okay, so from today you can see here. From today you can see these all the recordings will be placed here from the today's class onwards. So from yesterday's class onwards. Why? Because it is taking a couple of days. Why? Because it's a very new batch. For 1 to 2 days, they will be taking some days to calculate and to record the memory and so to record the videos in this block. But today, end of the day, you can see all the recordings. Okay, I'll also inform
Okay,
to the support team.
got it. Thank you.
Thank you very much.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to visit our Vimeo page and follow for more upcoming videos.